Hi there. Today I would like to show you a part of the language that I'm working on. Right now I'm working on the parser and on the lexer, and I'm trying to write it in such a way that it is relatively little code to work with. And one thing you can do to keep the code small is to structure your meta structure of the program in such a way that it represents something where you would usually have to have a lookup table or something. So right now, because I structured my expressions in this way, I can ask, does this expression modify the left-hand side as it does with the assign expression and on the operator assign expressions here. You just have to do two compares. You check if it is less than or equal than that, or greater than or equal than x per sign, and you know that you have an assignment expression which will modify the left-hand side. And that also has an impact when it comes to the precedence of the operation. So I think with that out of the way, this structure for binary operators can be used quite well. Now, why am I defining a macro that has these enum members in it? Well, the reason I use it is in that way is to be able to generate a toString function automatically. You can see in here it does define the type using a macro that invokes other macros. And if we look at the parser C file here, you can see there's a for each expression here, and this macro substitutes the name of the macro. Oh, by the way, this variadic parameter isn't needed anymore. Substitute the name in the case expression, and the result is that name turned into a string, and then we break out of this loop. So when you substitute this, it would say for each expression case such as xbad equals xbad, and this is not the best thing. Like, the best thing would be if I could just have the declaration as it is, but since I do not really have to go there very often, and the meta data has the enum member names in it, it's not such a loss to have it defined via a macro that invokes another macro. And like I said, it allows you to have a way to have these enums have a toString function defined automatically. Now, one of the important thing is now to get the tokens that are used to recognize these expressions, to have them in the same order as they are here. That should work quite well. It should be in the meta Lexa. So the meta Lexa H has a definition of the tokens, but they are not in the same order. They are defined as binary tokens, but they're not in the same order as the expressions, since I reordered the expressions. So now we have to make these things match. And the easiest thing is to just detach the editor here, so I can look at my things over here on this side and look here. So we can see that token arrow, token dot is in the same order as this, and so is the add expression. But the add sign expression is not, and what I'm doing right now will become apparent soon. Essentially what I did is I took the same order that these are going in, and then we will quickly see. If I take this and I put it after a sign, and then I take left shift to sign, put it here, right shift to sign, put it here, and then I am taking left shift and right shift and put them under concatenation. Here. Then I'm removing the spaces between those. All of them are in a big happy family now, and they should now be matching up. So let's see if they do. Add sub mul div plus minus there we go. The star token is not in the right position. Now it is. Add sub mul div XOR OR, and I forgot OR. Oh no, OR doesn't go into here because it's it doesn't have a corresponding sign. OR and end go in the middle here. And now right shift left shift concatenation and right shift left shift concatenation and or XOR diff mul sub add or XOR diff mul sub add. Okay. So now they are in the same order. I think these are 2. No. The multiplication was at the wrong point. Mul diff XOR OR and concatenation left shift right shift equals not equal less than less equal greater than, greater equal, and then the last binary token, which should be the spaceship. And it is. Okay. That is good. Now the only thing we have to do is we have to change the C file, which contains a test, and that test also relies on the order in here. And we can simply start with what we did before. We just consolidate these things. Under each other, and then in the end we take and we put them into right after the here the times is at the wrong place. Now it's not anymore. Okay. And now all of these go after a sign. Then comes equals equals as a delimiter, and all the comparison operations go together, and then this operation goes behind a minus, and then the or and the end went before the equals. Not sure if they're in the correct order. Okay, plus, minus, times, division. Plus, minus, times, division. XOR and XOR and tilde. And then come the shifts. which are not in the correct order. To take them out of here. Left shift, right shift. Alright, then comes our. So now these should match with those. Shift equal comes node. Alright. I think these match now the way they should. And we can test that by running our tests. Just say run tests. Oh, right, this is not the... No, this is the right directory. So that means the tests just succeeded. Well, I mean, let me make sure I'm testing this. So now that I changed this order, the test should fail. And now run tests. Oh, it fails. Alright. Which means the order is correct. Well, that is good. Let me sync. Okay. Synchronization should be ready soon. And the test worked. So when this test works, I guess we should be able to do a neat thing now, where we can go into our parser bin x type from tokens. You see, we have a switch here, but now this is no longer needed, since we know that these things are in the same order. So what we can now do is something quite neat, where we can say we can ask if the token type is greater than or equal the first binary token token self. This is the way that you can use these macros. If you wanted to evaluate to itself, what you have to do is you have to have a macro that then says evaluate to yourself. So because you have to call it with a macro, you can't just ask for the thing. So now if the token is greater than or equal to the first binary token and the token type is less than or equal to the last binary token itself, in that case, you return the token type minus the difference of the first binary token and the first binary expression. So we don't have this first and last expression yet. We should get them. Well, I think I have a first expression defined somewhere. Let me have a look at the definition of meta-C expression types. I should probably do... yes. I have exp bin invalid, which is one before the first binary expression. I don't think I want to keep it that way. Let me see what happens if I remove this one. Well, I have to find that out by actually removing it, I guess, because otherwise it messes up the macro. It doesn't seem to be any worse off without it. Maybe I can get rid of bin exp max as well. Yeah, it doesn't seem to be used. Then I can use the same trick that I used here. First expression type, token self, and then I just have to define these. And meta-C parser h. Define first binary exp m is exp comma, and then I have to add it in here, first binary exp m, and the last binary expression as well, which is the spaceship. So just remove it from here, make its own define, last binary exp n, and it just does spaceship, and in the end I added a here last binary exp, and that's that. Press binary exp. So now and this only works if I cast this to an end, this to an end, this to an end, and then take the whole thing. I can use my little cast macro. And then I take the whole expression maybe I can cast that whole expression into meta C expression, or I type T, yeah, this doesn't play anymore. I have to say type greater than or equal to first binary expression doc self, and here same greater than or equal to last binary expression doc self. Well, this essentially asks the same thing where I say is binary exp. Was it exp or exp with a capital lowercase? Okay. And then we try the expression type. Okay. So now this compiles, so if it actually properly works, then we can say A and B as an expression, and it should tell us that the next binary operator is an OR. It does that, and or B should give me the next binary operator OR. But something seems to not be quite right. So for plus it works, for or it doesn't. Oh, it could be that binary expression type to cars, that yes. So in the case where I don't have an explicit string for the operation, it will simply print garbage, which is why you see stuff like this. So if I were to give a string for exp or, for example, exp or, like that, and a very one for at the end as well. then I would recompile it, right? Simply go to here, recompile the thing, and now you would see if I go into expression mode and said A or B or V, that it can print it now properly, right? And it could do the same for right end. Just have to go into expression mode, do the same for right end, and then if I did that for, I don't know, x or equals, right, it would print garbage again because that's not in here, right? I can now write all of these out by hand, and frankly it's not that much, so writing it out by hand will be fine. I just add asses onto here, equals, 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 and Aurora and I already have. Then I kind of want to have them in the same order as I have them in my expression definition. So let me detach this one, no, not log. Detach it from the editor. So I have div mul. Now I have to use XOR. Well, in theory, I could write my definition macro in such a way that it would include the characters that have to match for this, for the tokens. Because what I can now trivially do is go back from a type to a token, or I could use my toString function, but I want it to be readable as an operator. So yeah, I'll just write this list myself. But what I can do is having a replacement in here saying that gets replaced by case colon, and then I have a little bit of stuff that I don't have to replace by hand. There we go. And now I can just put the string format. That's why I don't want to do it by hand. Boop, 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 boop. Move on that left. They're closing the right braces. If I'm going to have it all neat, then I might as well do it really neat. Okay, There we go. Then the little or were before the assign. Okay. Now let's do XOR or and concatenation left shift right shift. Nice and neat. I like that. And now I need to add these in their assignment form. There. And then I have to add the equal signs. Now comes equality and inequality, and then greater than, greater, equals, less than, less equal. The same with greater than. I will leave greater equal, greater than, greater equal. And if I did all of that correctly, then when I type in an expression like this one, A equals B, shifted up by 14, ORed with A concatenated with C concatenated with D and this all seems to be correct. Let me see if I forgot anything. No. Greater equals greater than. These are all correctly done. XOR or and div and end and or I have as well. I have them even at the same positions. Yeah, I am quite happy with this. I have the dot, I have the arrow. The thing I don't have is the comma, which I have to have. Comma, return, comma. And the other one that I also have to have is a spaceship operator, which I'm not quite sure why I even have that. And that now forces me to change all my indentation yet again. Oh well. There we go. We have computers for this kind of thing. Technically I have to. Alright, let's do this game again. Could have done this with a nano keyboard macro and it would have been much easier. But sometimes an easy thing gets you into the zone, in the flow. It's not always good to do things that are too difficult, so sometimes nice and non-difficult things are appreciated. Those are okay. So now we have this thing which will apply to every binary character, to every binary expression, and will properly print out the operator. The next thing we should do is precedence. And for this precedence thing, we could even shuffle them around again, so their position inside the list of operators also encodes the precedence they have. That would be an option. And I kind of like this, since I don't have a real auto constraint on it. So let's make sure the tests work. We did an eyeball test. Now let's make sure the tests work. The tests do work. Of course, we aren't testing. We aren't testing the implementation of these operators. Okay, no trading white space. All good. we probably should test that they're getting parsed correctly and that the print and this printout thing does the correct thing, but I mean, this is easy enough to read, so I'll give it a pass for now. And ideally this table would be auto-generated from the token table, but I'll leave it as it is for now. We go to the REPL, build it, run it. Then we can have an expression like a dot b dot c arrow e arrow f, and this would be parsed correctly. So that makes me quite happy. Although I'm not sure if this ordering is correct. Like if I take the address of that, E. Oh. This is unexpected for parse expression. So apparently I'm not dealing with taking the address of something. This is state dependent, actually. Whether something means taking the address of it or not. In 323 it failed. Okay. Well, one thing we can do is else if token type equals token, what's that? And then the thing we want to do is an address of expression. It parses an expression by itself. The hash of that would be the CRC of this. And this would be expression ADDR. Same here. And then we push operand result. And maybe we have another one. Else if token type equals token star. We allocate xptr Okay. Now, if we write the same thing, we should get something. So say, take the address of A dot B. And it tells me it doesn't know how to print address expressions, which is fine. Print expression. It's easy to add. I'll just add it to the place that prints eject expressions. Well, that's not a keyword expression actually, so let me give it its own. Its own place, where it basically works the same. This would be pointer expression. Where we said that, and then we basically go, if it's not a binary expression, put parentheses around it. Well, this is all duplicated code, and at some point I should consolidate this. But, right, who cares? I could say is unary operator or is unary expression, but, Now if I do this, B, address, like that, you see that it takes the address of a arrow B, and if I have a dot here, then it would do that as well. So if I now wanted to take the address and do +7, for example, like this. This is of course not what we want. What we want is actually this. Oh no, what happened? Is it really the case that it cannot parse this particular expression, or did I have white space at a place where I didn't expect to have white space? Like that. So that's interesting. Because that tells me that I'm not treating the expression correctly in here. Like when I push operands, I'm not pushing them balanced, which means that well, where is it? Here. When I pop the operator, it'll fail in 271. So this is when it pushes, when it pops the parentheses. And this means that I didn't push an operator when I should have pushed an operator. For the address expression. Oh, I push it, but I don't pop it. Pop operator. Same with these, by the way. So now, if I write the same expression that I did just now where it failed, this one, it should now work. Q build after building :E, paste it in. You see now it doesn't fail anymore, and it does what it should do, as in it takes the address and then it adds the 7 to this pointer that would have the type of A.B. So let me add the type of keyword and the type of expression. Adding a keyword is very easy. All I do is I go into my for each keyword token, and all I have to do is to go say m token keyword type of. That's it. That is all that had to happen to add a new keyword. If I now run this code again, I can simply say type of, and it says token identifier type of. Oh, yes, one more thing has to happen. When I add a new keyword, I have to generate some code to look things up in the keyword table. So I have to run generate code.sh. It's done now. So now, if I go into my REPL and I build a new version of it, and now I use my REPL and I say type of, it says keyword type of. Isn't that nice? And the code that had to be generated is in generated, which just matches certain tokens, certain identifiers against certain pre-written names. And this switch here has to be generated at compile time, because this hash number, this identifier key here, forces me to use a hash function which I'm not comfortable writing as a preprocessor macro. That's why it looks like this. Well, if I wanted to, I could do an if-else chain, and within there call the hash function and rely on the optimizer of the compiler to make it into a constant. But I kind of prefer using this case statement thing. There is one thing that I want to change about this generated code. That is, I wanted to print a little bit of, let me quickly see if that is in my remote, so I don't have to write this again in case. Okay, no, I have to write this again. It's quite easy, it's just one. If and f. So if I'm not on the Microsoft compiler, I want to use find memcomp as built-in memcomp, built-in memcomp, and what this will do is for GCC compilers, it will then use the built-in memcomp, which means that it will generate somewhat better code. So I'm not even sure if sync2 includes this tool. It does include the tool. Okay, so I can just sync that to my remote. And you can see it takes quite a while to access the remote drive, and everything freezes when I have file open that is like when the remote gets disconnected and I have a file from the network file system open, everything freezes up, which is why I usually use these scripts to mirror the content of my remote file system with my local file system. Anyways, we should now be able to even write an expression with the type of init. Maybe. I'm not quite sure because maybe it's not being seen as a unary operator, but we can say int plus type of 2, for example. And maybe this won't get parsed correctly. In fact, I'm quite sure that it will not. It will tell us that it doesn't know what to do with the type of keyword. Yeah, there we go. Expected token type of keyword. Well, maybe let me parse the type of expression. Just because I'm just doing it. Parse expression let's see. There. So let me do this at the very last thing of the keywords. Else if token type equals token type of. There is no auto-completion for it since it's not mentioned anywhere. Oh, yeah, it's token keyword type of. Now it finds it. Yeah, right. If it is a type of thing, then allocate the expression let's see. Let me see where in terms of keywords is my type of is before enum and before inject. Well, then let me put it here and exp type of. Now I have a type of expression type, which I can then in the parser parse. What this does is it matches. Well, actually no. I want to parse the parenthesis expression, but I then want to remove the thing after it. You will shortly see what's I want to parse this, right? But then, because I know it'll be a parenthesis expression, I pull out that level of parentheses that just gets removed. Yeah, so what I do is, what's it called again? Meta C expression T star paren exp. I can say peak. I should be able to say peak, or I guess it would be called meta C parser peak token. Self. Is it called self? Parse expression. Does parse expression have the self? Yes. Meta parser peak token self, and I want to peak one token ahead, and then I say if that if not, so if it can't peak one token ahead, well, what's the return type of that again? Okay, it's a token pointer, so or meta C or meta C token T next pointer. So if there is no next token, or the token is not token help paren parse error. So do have a state. I should have a parser state, but apparently I don't have one here. Oh, this is the Lexa state. That would be in parser. It would be self Lexa state. Right, and the parser error would be expected that will be followed by that. So this seems to be correct though. This should be this define. And oh, it's defined in Lexa C. It's not defined in Lexa H. Right, let me define this one in Lexa H. Because that would mean that I would get that. Actually, let me put both in the H file. After the type definitions, before the function definitions go. And then the parser. what in the langauge here. That's what I wanted. And I guess for that I have to include an outside type of A. This should parse properly, I think. The E. And it doesn't. Instead it fails. Oh, well. No. Type of 12. And it tells me it doesn't know how to print a type of expression, which means that this worked. Which also means that if I forget to put the parentheses, it should tell me that. Wow, it looks like the parse error hit. I'm not quite sure what the reason for it breaking is. I guess I have to use GDB, which will more helpfully tell me. Go to expression mode. Type of 12 works. Do the same thing without the. There we go. Type of followed by N. And the failing thing here is the F check. I guess if I want to know what this really says, I have to run it without the debugger. Type of. Oh no, I just get a seg fault. That's great. Oh, the state can't be null. Well, I can quickly fix that. There we go. That way, if the state is null, it won't matter. So now I can do that. And it says expected type of to be followed by parentheses. And if I now do type of XX close that, P colon E, right? It tells me it won't know how it prints type of expressions. Printing a type of expression, it's easily implemented. Print expression. Simply go to there. In the meta C parser, there's a place where I do the unary keywords type of, and in that case I want the operator to say type of. And since it parses a parentheses expression, this will just give me what I want, I believe. I just have to, in this if like that. Well, and sometimes you have to put your semicolons. Type of x. Then I can do type of x plus y. And that I get properly as well. So, the reason this prints is because I'm getting a parentheses expression under the type of expression. That's not what I want. What I want is for this parentheses expression to not be the weight. This is actually what should be happening. I am parsing an expression which is a parentheses expression. But so let me assert that this is actually the case. So param x type should be x paren. I believe. Which then means that whatever is inside the parenthesis expression should then not be do we peek for the token? No, we pull the token, we don't use peek, which means that the type of token is being used. E type of x. And the result is for some reason yeah, so this is correct, but I still don't know why there is this paren here, since what E1 equals paren exp E1 means is that the result then should not be, the result E1 should not be a paren exp. So I'd like to know what's going on. Printf exp paren exp E1 type colon %s comma meta c should have a meta c expression to cars. Do you have expression type to cars? I don't. Well, luckily I can generate that one. Oh, it's still called metal. It's supposed to be called meta C now. Meta C expression type to cars. There we go. And a new line after it. Wow, okay. This should work. What? Why does it have conflicting types? Oh, because I don't declare this one, and I should. Metal X type. There, this one is now meta C expression type to characters. Now try this again. Type of X. And the type is an expression identifier. Could it be that I print the... yes. That's the issue. I have this in my printing of these keyword arguments that I will print parentheses around them. Right. So yeah, no worries. This works exactly as it should. So no need for this print. Yeah, this is exactly what should happen. This is great. And with that, I think I have done enough for today. Tomorrow we are going to work on the operator precedence issue. So I hope you're excited for that. Good luck.